So kalpas exist across. That word is specifically, I believe, Hindu, but that the ideology of it spreads across multiple religions, including Norse. And the Norse version of it, they refer to it as Ragnarok,
Yes.
which, progressionally speaking, and as far as like the words that are used, I feel like are more literal. Because Ragnarok is basically the universe ends and begins simultaneously.
Yeah.
So in a way they kind of understood that like life happens in a circle, because with in Norse mythology everything happens within a circle. A lot
Yeah.
of their art, even like the shape of their shields,
Hmm.
like everything was a circle. So I honestly I straight up think that the Vikings had an understanding that the universe expands and contracts, and the contraction would be like the end and the expansion would be the beginning. So Kalpa and or the Ragnarok idealism kind of gives credibility that the universe implodes and explodes in its time frame
Yeah.
constantly.
So I do know there's a theory suggesting that when the universe does end, it will start over again. Like essentially, it'll end, then there'll be another big bang, and essentially we're essentially doomed to repeat the same things that like we're gonna do episode 3 all over again in another time.
Forever.
You're stuck with us.
Forever.
And ever and ever and but yeah, it's kind of, but yeah, to kind of go back to the whole the expansion of the universe essentially. But yeah, it is currently doing it at a rate about 70 kilometers per second for every megaparsec, and a megaparsec is about 3.26 million light years.
Hmm.
So essentially, you take 70 times 860,000, and essentially it's going to be the universe is expanding faster than the speed of light. The further out you are from it. So essentially, so that'd be like if I put you in a swimming pool and told you, "Hey, swim to the other side." But as you start swimming, the pool gets longer.
Hmm.
So it almost feels like you're not even moving at all. Not only that, but it's expanding faster than you can swim.
Which, kids, is why the laws of acceleration in space versus the laws of acceleration on Earth are vastly different.
We're talking about the cosmic level here. Again, that's the observable universe. That's just what we can see.
And with our current state of technology, it's basically, hey, go from this end of the universe to the other. And then the answer back to that would be, how?
Right? Because, like I said, unfortunately, we can't even create, and not even so much that we can create, spaceships that can travel, at the speed of light, but essentially the faster you go, the more dense you become.
Mm-hmm.
So essentially, if you did create a spaceship that traveled, at the speed of light, it essentially would collapse in on itself for how dense it becomes.
That's true. Which, interestingly enough, now that I'm thinking on it, most of like the sci-fi, um, like movies and TV shows and stuff like that, like
Yeah,
I believe Star Trek invented faster than light travel,
they did, yes.
because they never refer to it as like light speed.
It's warp speed.
It's warp speed because it's faster than light travel.
Yeah. Essentially, the concept is that, whatever, speed you put it in, it charts, because you can't just go exactly from one point to the other
Mm-hmm.
through space, because you're talking about asteroid fields, pulsars, quasars, gamma radiation, black holes, you know, dark nightmares of death, and probe the universe. So you kind of have to, like, if you were to do this, Star Trek space travel,
Mm-hmm.
you have to plot that course. And the only way to do that is if you essentially warp time and space. So, like, again, through wormholes, you pretty much fold space and time.
Mm-hmm.
So let's say, you ask the question, what's the shortest point between, not shortest point, the shortest distance between 2 points. Our natural line of thought is, a line, a straight line. No, you pull up a map on, the U.S. map and you say, hey, get on Route 66 and go from one side of the country to the other.
Mm-hmm.
It's linear. It goes in a straight line. But think of it this way. You tell you, hey, go from this side of the country to this side of the country. Okay, but you have to do it, almost instantaneously.
Mm-hmm.
How are you going to do that? fold the map, fold space and time, and then those 2 points will be right next to each other.
Mm-hmm.
Just go through that, so theoretically, of course, so like, so when Star Trek talks about, warp speed, it's the concept of folding space and time.
The literal fabric.
Yeah. And again, space and time, according to Einstein's, theory of relativity, is, space and time is relative. I tell you from one side of the universe, let's just say that the universe isn't expanding.
Mm-hmm.
And, and you're told to go from one side to the other at the speed of light, taking 93 billion years. It would take you 93 billion years to go from one side to the other, assuming you can live forever. But every other, like, human, animal, microorganism, that exists on Earth would essentially be gone. You would not know them to exist anymore because in your relative, time, you will age at 93 billion years. But since everything else is obviously clearly moving slower,
mm-hmm.
like, so a cheetah can only run like 60 miles an hour. That cheetah is like long gone by now.
Only 60 miles an hour.
Only 61 miles, absolutely not. Fuck that shit. No. But for all intents and purposes, yeah, 60 miles an hour. So again, space, so that'd be like, for all intents and purposes. So the nearest star to the sun is Proxima Centauri, which is about 4.25 light years away.
Mm.
You're given the opportunity to, travel at the speed of light to go to this star. It'd take you 4.25 years.
Mm-hmm.
And you're like, okay, we'll report all your findings, then come back to Earth. You go back to light speed, take another 4.25 years. By the time you get back to Earth, probably every civilization will be gone. Because what was 4.25 years to you is, if not millions of years removed for Earth. It's again, space-time relativity.
That's weird concept because we got lunch earlier and
mm-hmm.
we were talking about basically time dilation involving black holes.
Yes. That in itself is freaky.
Mm-hmm.
As again, perfect example, like I said, they say Interstellar, as far as like the movie Interstellar, is right up there as being like one of the most scientifically accurate films from like a science fiction standpoint.
Mm-hmm.
It is actually what was that author's name? His name was Arthur C. Clarke. He's pretty much, coined the phrase of like what it, like hard science fiction. Yeah. So essentially science fiction that adheres to the laws of physics.
It implores realism.
Yes, exactly. Implores realism. So essentially, that one planet that they visit that's like all water, and they hear that ticking noise. Like I said, 1 second on that planet due to space, the space dilation, time dilation, 1 second is 1 day on Earth. So essentially, from the time Interstellar came out in theaters till now, an hour and a half has passed on that planet.
Mm-hmm.
But of course, Interstellar, oh God, when did that movie come out? Like what, 2015, I think? It's been 10 years?
15, 16, somewhere around that area.
Yeah, so, again, what's 10 years to us is only an hour and a half on that planet.
Mm-hmm.
Because I said, pretty much the thing that's crazy about black holes, the more we understand them, there's multiple theories saying that, one, our universe lies within a black hole. That's a theory. There's also been the theory for the longest time that if you were to enter a black hole, you essentially get what is called spaghettification, which is essentially you're stretched out to oblivion. There's that theory. There's the idea that if you fall into one, you would essentially see space and time fold around you. Like you were saying, it would essentially look like a mirror.
Yeah, it would be like a full mirror all the way around you.
Yes.
And you would be able to see three-dimensionally yourself.
Yep. But the thing is, what's crazy about black holes is that they actually have planets that do orbit them.
Mm-hmm.
They are far enough away that they're not getting sucked in, but they're also close enough that they can be sustained within its gravitational pull, which is immense, by the way. Keep in mind, so as of right now, the biggest black hole that we know of is Ton 618. This black hole is 66 million times the mass of the sun.
And it is aptly named.
Very aptly named. Essentially, our solar system would be like a grain of salt compared to a basketball, as far as just to give you an idea of how massive this black hole is.
Not Earth, the solar system.
The solar system, the thing that, if you were to travel right now from Earth to Pluto, it'd take you 42 years at the speed that we would do it. Yeah.
1% the speed of light, I think, is the fastest.
Yes.
We can travel within the means of our current technology.
Yes. So
that we know of. Publicly.
That we know, yeah. But like again, that's just how massive this black hole is.
Yeah.
So,
and the crazy thing is, relatively speaking, you have like speed freaks, people who love to go fast.
Yeah.
If you were to place a person with that level of interest on a spaceship and fly them out into space, it would feel like you are going insanely slow, relatively speaking, which is another thing that boggles my mind.